Alright, hello everyone. So if you're watching this, hopefully you've got a Chromebook, maybe have some headphones in, and have your lesson sheet. We're going to go through, just review a few of our things from Friday, and then get into doing a few more things with volume. You want to have that green formula sheet handy, and just remember our key ideas from Friday for any prism at all. The volume of a prism, how much 3D space it takes up, its capacity, is the area of that prism's base times the height of the prism. When you look on your formula sheet, when you see the formula for the volume of a rectangular prism, it's given as length times width times height. But that's just because the area of a rectangular base is length times width. But in general, you can always find the volume of a prism using this general formula. And sometimes if you want to use a shortcut, you can use these formulas too. And then we saw for a pyramid, and you guys will have this fixed on your updated sheet. For any pyramid, the volume of a pyramid is area of the base times the height divided by 3, because we saw that a pyramid fits inside a prism exactly 3 times. Alright, I have a little bit of a warm-up for you guys, a few warm-up questions to get started on. You guys are finding the volume of the 3 shapes I've given you. So you could pause the video at this point if you want to give them a try on your own, and then just replay it to check your answers. Or you can follow along with me too if you would like. So first we identify the shape we have here is a rectangular prism. And I think it's really simple for rectangular prisms to find their volume. The formula we worked with on Friday is just so quick, and we see this, that the length times width, that just comes from the area of the base, right? But you guys can always, for a rectangular prism, you can easily and quickly do the volume of a rectangular prism by doing length times width times height. So just picking a value for L, 4, 3 is the width, call height 15. We can do this really quickly. So 4, in brackets, that just means multiplication, times 15. And you guys can do that quickly and verify we get 180. And the units would be centimeters. And because volume is how much 3-dimensional space an object takes up, we have the units are centimeters cubed. So that's our rectangular prism. Next up, we have a triangular prism. Because it's 2 identical triangle bases connected to each other. I'm going to do this one 2 separate ways. So if you just identify the base, maybe shading it in, this is a triangle. The area of the base is pretty easy to calculate. Your base times height divided by 2. I mean, we've done a lot of areas of just basic shapes as well, so hopefully this is pretty easy for you. So 8, the height of that triangle is 3 divided by 2, that's 12 meters squared. And then if you wanted to find, we want to find the volume of our prism, and for any prism, we'll just do base, the area of the base times the height. Well, we found our base area is 12. The height of our prism is also 12. And so the area of this triangular prism is 144 meters cubed. And this is very straightforward method, finding the base, multiply by the height. Or, if you'd prefer, your formula sheet does have a shortcut for triangular prism, and it looks like this. It looks like B times L times H over 2. And this isn't contradictory to what we just did. Remember, the volume of a prism is area of the base times its height, and the area of a triangle base is just base times the height of the triangle divided by 2. And on your formula sheet, you can see that they label the height of the triangle base with a little L, and the height of the prism is h. And if we plug those in, so base of 8, triangle base height is 3, height of the prism is 12, and you just divide that by 2. And you can check, you get the same thing, 144 meters cubed. So if you feel like you want to just use the general formula for any prism, that's fine. Or if you feel comfortable using the formula sheet, little shortcut, then you can shortcut. And you can do that too, as long as you're comfortable. And then for our third one, this is a pyramid. And we talked about how, for a pyramid, the volume of any pyramid is the area of the base times the height, just like a prism, except what's a pyramid? And 3 pyramids fit inside a prism, so we divide by 3. In this case, our base area is just a rectangle. So you may wish to do this off to the side. Base is a rectangle, 6 by 4, 24 meters squared, and then you can just do that, use the 24 in your formula, and the height of the pyramid here is 10 divided by 3, and we get 80 centimeters cubed. But it's really easy to find volume of pyramids. No more difficult than finding the volume of a prism, area of the base times the height, but in the case of a pyramid, you just have to remember to divide by 3. So that's a little review of what we did Friday, and this is also stuff that you guys did in your grade 9 course, so hopefully it feels like a bit of review. Today, we're actually not learning a new concept, we're just applying it to 2 new different 3D shapes. We're going to be finding the volume first of a cylinder, and then of a cone. So a cylinder just fits in with our previous day's stuff, because a cylinder is nothing more than a circular prism, except that can be a mouthful. We just call these cylinders, like a can shaped. And the 2 things you need to calculate the volume of a cylinder, you need the radius of the cylinder, which is like the radius of the circular base, and you need the height of the cylinder. So you can do cylinder volumes the exact same way you do any prism. So for a cylinder, the volume is just like before, area of the base times the height, because it's a prism. But there is a nice tidy shortcut formula if you'd like to use that. It works pretty well. Because the area of that circular base, well, it's just a circle, and we know the area of a circle is pi r squared. The volume of a cylinder is pi r squared, and then also times the height. So this is a bit of a shortcut that a lot of you guys may want to just start using. And again, it just becomes from the fact that pi r squared just happens to be the area of a circular base. So all of our work is just going to be recognizing the shape and then just choosing the appropriate formula and just evaluating correctly. Let's try a little example here. So I've got a cylinder here, a soup can. We're going to find the volume of the soup can to see how much liquid it can hold. So you can see we have the height of our soup can. And what I actually want to emphasize is sometimes we're not given the radius. Here you're given that the diameter of the soup can is 5 centimeters. And at this point in our math careers and after all the examples we've done, we should be pretty comfortable just saying, okay, I know the diameter, I know the radius is half the diameter, so 2.5 centimeters would be the radius. And we're good to go to find the volume of this can. Volume equals, I really like using the pi r squared h formula. It's just nice and quick and tidy and efficient. Again, just because pi r squared, that just is the area of that circular base, right? Because you can just go right to plugging in your stuff. It's really easy to use. So 3.14 times 2.5 squared times 10. And you could punch that in as you see it, those of you guys who are comfortable with your calculators. If you're more comfortable using multiplication, you could write that like as this, like 3.14 times 2.5 To square 2.5 means to multiply it by itself. So both of those work just fine, whatever you feel most comfortable with on your calculator. And that's just a quick calculation for us to do, and you guys do it too. If I go to one decimal place, actually no, I'll just round it, I'll just keep it exact here. 196.25 centimeters cubed is how much liquid that can could hold. So very easy, manageable to find the volume of a cylinder. You guys can all do it. The final shape you guys are going at today is a cone, because and the volume of a cone is actually pretty easy to find too, because as we saw on Friday, remember that for a pyramid with the same base and the same height as its corresponding prism, 3 pyramids fit into the corresponding prism. I showed that with that little quinoa demonstration. So we can apply that idea to cones, because a cone is just basically it's a pyramid with a circular base. It's like the cylinder version of a pyramid. So the volume of a cone is exactly 1/3 the volume of a cylinder. So for a cone, the volume is this volume of a cylinder divided by 3. So just like a pyramid, you can think of it as the area of the base times the height, because that's how you find the volume of a cylinder. Cylinder is just a prism. Just divide by 3. Now in the case of a cone, we can use this nice tidy formula, just actually because the volume of a cylinder is just pi r squared h. To get the cone volume, you just do your pi r squared h, and then just in the end you just divide by 3, because it's a cone. Very straightforward, but that divided by 3 comes because a cone is just the pyramid version of a cylinder. So now that we've talked about how to get the volume of a cone, and that formula appears on your formula sheet, it might look like this though. It might look like pi times r squared times h, but just over 3, which means the same thing as dividing by 3. Let's just do a quick example or two, and then you guys can work on some practice. So actually, the derivation we did up here, you guys can pop in here. So we just kind of summarize this. So for a cylinder, area of the base would be pi r squared, and then we have times our height, and then as we just talked about, for a cone, pi r squared h divided by 3. So yeah, sorry, just did that twice. Let's just do a couple examples, real quick ones. So I've given you guys a cone here. We're going to find its volume. I mean, I can only make these like so tricky, right? Like in this question, you don't have the radius to start. You have the diameter is 10. So you just have to do a quick calculation of dividing that diameter by 2. Sometimes you'll be given the radius directly, but here we got to do that division first. And then we have the height of our cone is given to us, and that's all we need. Like we can all do this. Volume of a cone, we have all we need, the radius, the height. So start off by writing your formula, pi r squared h. And I'm just, for this one, I think I'll just write the divided by 3 like that, because I think that connects with a lot of people. And then we just have to plug in what we know. 3.14 times 5 squared times 9, and then divided by 3. And yeah, after this, at this point, just hammer it into your calculators. Just be careful. If you feel like you're more comfortable writing it as a string of all multiplications, just write 5 squared as 5 times 5. So when I do this, I got about 235.5. And the units would be meters cubed. you can all do it. Just recognize the shape, it's a cone. Choose the appropriate formula, and then identify what we need. Radius was 5, and the height of that cone is 9. Why don't you take a moment and try this next one? You actually just have to draw this cone, so why don't you just take a moment and try to draw the cone. You can even pause the video if you want to and try this question on your own, and then you can just replay the video and check your answer, or if you want to, you can just follow along. So I'll just take a pause right now, and for those of you that want to turn it off and try it on your own. And otherwise, yeah, if you've unpaused it, we're ready to take it up, or you're still with me, that's fine. Let's do this. The paper cup, I'm sure a lot of us have seen this at just like water coolers and stuff. Paper cup looks something like that. And here we've been told the radius of our paper cup is 4 centimeters. So that's nice, we just have that directly. And then you can label your height inside the actual cone if you want to, like that, little right angle there. Or if you, put a little arrow, so the height is 10 centimeters. Or another way you might see that in some diagrams is just a little vertical arrows like this showing the height is 10, whatever you prefer. They both mean the same thing. Oops, just ignore that. And yeah, we have all we need. Like, everybody can do this. Hopefully you guys are building up some confidence when you're just doing your practice, but we just got to know what our shapes are, know how to choose the appropriate formula, and you all have your formula sheets. There's no reason why we can't. Just be able to recognize what we need and what those are from the diagram. So here, pi is 3.14, recognizing our radius here is 4. And I'm going to do the 4 square for this one. And our height is 10. And the end, because it's a cone, dividing by 3. And if you're using a display calculator, it's really easy to punch in all in one step. If you're using your phone or something, you just got to be more careful. Your phones sometimes can lead you astray with some order of operations, just the way you punch things in. But I got 167.5 in the units centimeters cubed. Alright, so we've kind of reviewed Friday, finding the volume of a prism and a pyramid, and the big ideas were for prism, area of the base times the height. For a pyramid, area of the base times the height, but divided by 3. And then we reviewed some of those shapes up at Friday, talked about how there's some specific formulas. And then the big ideas for today were to be able to find the volume of a cylinder. And again, it's just a prism, area of the base times the height. Has a special shortcut formula on your sheet that's kind of nice to use. And then we just talked about cones. Cones are just a pyramid. So we take the volume of a cylinder, just divide by 3. Get a nice tidy formula too. And yeah, so you've got some practice on finding those volumes. Some of you guys have, let me just actually jot this down. So a lot of you will just be working on practice for today. Some of you have assignments on the go still that you'll need to finish up. And if you've done all your assignments and you do finish the practice, your supply does have some extra practice that you can work on. Tomorrow you will be doing an assignment based on this volume stuff, and on Wednesday you'll be doing another short little video lesson like this one, just on spheres, and then we'll be ready to move on to surface area together when I come back. So yeah, please continue to work hard, get your stuff done, and I will see you guys within a few days. Bye-bye.